Hello, I am Sümeyye Ayfer Akbaba, and now I am presenting my power electronics course project, which is an isolated DC-DC flyback converter, which converts 7 volts of input voltage to 17 volts of output voltage. First, I calculated my theoretical values and then did a simulation putting these values to see if the circuit works with these values. I also wound my own transformer also according to these theoretical values. Then after I see that the simulation works satisfying the requirements, I drew my flyback converter in dip trace in order to print out my PCB for the circuit. So this is the schematics of the DC-DC flyback converter. So this circuit consists of 3 main parts. The first one is this switching regulator. This basically switches on and off through the primary side according to a duty cycle which is determined by this timing capacitor. This switching behavior causes a magnetic field variation on the primary side, and this causes an induction current to flow on the secondary side that opposes to the variation of the magnetic field on the primary side. So this transformer basically transfers the energy from primary to secondary. The third main part is the feedback loop consisting of this optocoupler and the shunt regulator. So this feedback loop ensures the output voltage to remain stable by giving feedback to the controller of the switch regulator. Also, this optocoupler provides the electrical isolation between the primary and the secondary, which is why I put different grounds for primary and secondary. And lastly, this output capacitor smoothens the output voltage. However, I needed to put a much higher valued capacitor in the implementation in order to reduce the ripple. So let's get back to the measurement part. My output is exactly 17 volts, the mean value, and these are my input voltage and input current. You can see the efficiency and output power calculated on the above. Note that the efficiency is relatively low, it's less than 50%, because the BGT could not be fully saturated. Now I'm going to show the output ripple voltage, adjusting the coupling to AC. As you can see, my output ripple voltage is around 64 millivolts, which satisfies the requirement that the output ripple voltage must be less than 300 millivolts. Moving on, this is the switch voltage measured from the output of the switch regulator. The voltage value shown is the input voltage plus the output reflected voltage on the primary side of the transformer. It's around 17 volts. I also want to highlight some possible reasons why your flyback converter circuit may not work or may not have the desired output voltage. First of all, you should always check for disconnectivities or unwanted short circuits by using the buzzer mode of the multimeter for the bottom of the PCB. Since we are not soldering with some professional soldering iron, the solder may spread to the other pads, and this causes short circuits. Second, you may not have fully sandpapered the tip of the copper wire you use for the transformers. If you didn't fully sandpapered the tip, you may have connected the non-conducting part of the wire, and this will basically cause a disconnectivity. Also, you may have put your transformer in a wrong way. You should check for the secondary and the primary if they are in the right position, and also you should check if the dots are in the right position too. This also changes the response fully. Another mistake that I have done is that I have accidentally put a component's ground wrong in dip trace. What I mean is that I put secondary ground instead of primary ground, which completely eliminated that component and caused my optocoupler not to work initially. And that's all I have to say, I guess. Thank you for watching.